Assalamualaikum and hi. My name is YUSOF. I'm from Group 4 and we are going to present our topic, the Orthoclase. Our group contains by 3 people. They are Muhammad HIDZER, Muhammad Nasrullah bin AHMAD AZIAN, and myself, Muhammad YUSOF. Okay, in this topic, we are going to start with about the general explanation about the Orthoclase itself, then the formation of Orthoclase, then we're going to proceed about the structure of Orthoclase, and next we are going to talk about properties of Orthoclase, and finally we will talk about application and limitation. Okay, as general, Orthoclase is a FEPA mineral with a chemical composition of KALSI308. It is one of the most abundant rocks forming mineral of continental crust. Orthoclase is monoclinic alkali FEPA that has the largest optical axial angle and look homogeneous. It does not show crosshatch twinning, while microcline is triclinic that has larger optical axial angle and exhibit the typical cross-hatch twinning. Okay, next. How Orthoclase can be formed? Orthoclase is found in silica-rich richness rocks such as granite and high-grade metamorphic rocks. Orthoclase form at intermediate temperature between the stability field of syenite and microcline. At 400 degrees Celsius or less, microcline is stable structure from KALSI308. Between approximate 500 degrees Celsius to 900 degrees Celsius, Orthoclase is become stable structure. And above approximate 900 degree, syenite is stable structure of Orthoclase. The difference between the structure is only randomness of aluminum and silicon atoms. In microcline, the atoms are ordered, and this produce the lower symmetry of triclinics. With higher temperature, the position of the aluminum and silicon become more disordered and produce the monoclinic symmetry of Orthoclase and finally cyanide. Next, we are going to talk about structure of Orthoclase. As I said before, Orthoclase is a member of alkaline FEPA series. This FEPA mineral form a solid solution series between NaAlSi308 and KAlSi308. The mineral is the series crystalline from metal that usually contain both sodium and potassium ion. At time of crystallization, this ion can substitute freely from one another in the mineral crystal structure. Because of this, alkaline FEPAs exist in a range of chemical composition between the pure albite that are NaAlSi308 and pure Orthoclase that are KAlSi308. A chart here summarize their continuum of compositional relationship as shown.
Assalamualaikum warahmatullahi wabarakatuh to Dr. Husnia, my fellow groupmates of Orthoclase, Nasrullah and SYAHIRAN. Now is my part to present about the physical properties of Orthoclase. There are several physical properties of Orthoclase that can be found and have listed on this slide, which is the first is the Orthoclase color. Orthoclase color can be found in the 4 or 5 color, which is the first is the colorless, yellow, reddish color, white color, and pink color. Next, the properties is the strict. Strict is usually the name of the test, which is the strict test. This strict test is the method used to determine the color of the mineral in powdered form. The color of mineral form or have been powdered is the often very important property to identify the mineral, which is this orthoclase mineral. Next properties is the luster. Luster used to known as a word to describe the light reflecting characteristic of a mineral specimen. This luster can be described of or can be example of the submetallic, non-metallic, vitreous, dull, and greasy. For the orthoclase itself, the luster, which is the luster example is the vitreous, subvitreous, and resinous. In terms of diaphanity, which is the physical of properties of this orthoclase, is the usually translucent to transparent, which is this can be explained by all feldspar mineral are usually translucent to transparent, and this usually display the two direction of cleavage that intersect at approximately 90 degrees. Next is the crystal system. Orthoclase have the crystal system named by monoclinic. What is mean by monoclinic? Monoclinic is the system of one of the seven crystal system that described by three vectors. In this monoclinic system also, they form a rectangular prism with parallelogram as its base. Next is the hardness or the data of the hardness of physical hardness data of physical properties of orthoclase also have described, which is sits on Mohs scale. What is mean by Mohs scales? Mohs scales is the most important test for identifying the mineral specimen to that this test compares the resistance of the other mineral and orthoclase. Orthoclase mineral have sits on Mohs scale. Next, the density or tenacity of this orthoclase physical properties is the 2.55 to 2.63 gram per centimeter cubic for the measurement, and 2.563 gram per centimeter cube for the calculated measurement. For the tenacity is the orthoclase has the brittle, and this conclude the physical properties of orthoclase for my part. Now I would like to present about the chemical properties and optical properties of orthoclase. Firstly, I would like to present about the chemical properties first. Chemical properties that used to be found or be listed in this slide is the classification of the chemical, which is orthoclase has the silicate mineral, and the composition of the orthoclase in this chemical properties is microline, which is the formula have been stated in this slide, which is used to name like microline. The chemical bonding of this orthoclase is the ionic bonding, And impurities that common be found is the natrium, ferrum, barium, calcium, and more. For the optical properties of the orthoclase is the color or pleochroism is the non-pleochroic, and the twinning is the common, and the common twinning is Carlsbad, Baveno, and Manebach. The optic sign that can be found in these properties is the biaxial or negative biaxial, and the surface relief is stated low. That's all for my presentation in this chemical or optical properties. Thank you.
There are some limitations of orthoclase, which is extension parallel to cleavage, no slow or fast length, low resistance to weather, brittle, low negative relief, altered to certified or clay, and the signal tend to fade of geological rate, distinguishable from microclimb by a lack of Bredon twinning, and distinguishable from cyanidine by a larger 2px. Now is application of orthoclase. Orthoclase is used in the chemical industry as a component of flux, and it also used in various proportions while making porcelain and earthenware. This mineral is also utilized in wall tiles and ceramic flooring tiles, as it improves their stretch and durability of the tiles. And the last is this mineral is mainly used as gemstones because of its transparent and translucent appearance.